Now we already know something about the Ethernet, right? Also, maybe we only know the early Ethernet, but we know what's the cable, what's the devices, what's the principle, and the typical one is what's the function of the MAC address and what's the format. And now if we see the modern Ethernet, in the first different one is we add a new cable, and this cable we call is fiber. And about the fiber, we have two types. The first one is multimode fiber, and the characteristic is we will use a thicker fiber core and the transmission of a variety of different wavelengths and the angle of the light. And pay attention, because we use a multimode fiber and it has a large attenuation and transmission distance is usually within km. But the advantage is it is low cost. Of course, compared with a single mode fiber, this is low cost. But if you compare with UTP or STP, this one is very expensive. And another one is single mode fiber. The difference with the multi-mode is the core is the same wavelength as light, and the transmit a single wave light. That means one cable you only can transfer one wave, but multi-mode fiber you can transfer multiple. And the advantage compared with the multi-mode fiber, we can provide a low attenuation and the distance is longer, but it will need high cost. So compared with these two parts, it's a little different. And if you want to use a fiber to connect with the devices, another one is we have also used the fiber connector. In the typical optical fiber connector like LC, SC, ST, and FC. Maybe in your network you also see this connector, right? And the fiber have to connect with the connector fiber, and then we can connect with the device. Then we can transfer the packets. And another one about the protocol. Early Ethernet, we only can provide the 10 Mbps speed, but about the modern Ethernet, we can use a higher bandwidth, like 100 and 1000. About the 100 Mbps we call is faster Ethernet, and about the 1 gigabit we call is Gigabit Ethernet. And we also have different protocol like AO2.3U and AO2.3Z, something like this. The first one change is the speed. The speed is higher. And the second one, we will use multiple media. Also, maybe we will use a UTP. We have different pairs. Like the first one, 100 based TX. The speed is 100. The media is 5 UDP 2 pair. But pay attention. About the new one, we will use the higher speed, and we will add a new media. We add the multi-mode fiber and single mode fiber, and we also still use UTP. And if we use the fiber to connect with each other, we can have long distance. For example, if we use a single mode fiber, the longest distance is 5,000 meters. But if you use a UTP, maybe your speed is faster, like 100 or 1 gigabit. But the distance also limits 1 meters. So pay attention about this one. This is the second difference of the modern Ethernet. The speed is higher and we use multiple medias. And the third different one is we use a new device, and this device we call it switch. And about the switch, working principle is different with the hub. When hub receives the signal, I only do the increase the signal to make the signal bigger and then send all the signal out. But about the switch is different. If the switch receives a message, I will check the MAC address table and decide which interface how to send out. So, of course, about the detail of the principle, I will explain in the next video. So, if we use a switch, the first one is switch can isolate the collision domain. That means if we use a switch like the middle one, we have 4 interfaces, right? One to connect with a hub, one to connect with switch, and the other 2 interfaces to connect with a terminal. These 4 interfaces, the devices connect with a switch. They can send the message at the same time, and there is no collision. So, this is the typical of the switch. We can isolate the collision domain. That means this is a further expands the range of the physical connection. Okay, so if you want to use a switch to connect with a terminal and the range bigger, it's okay because they belong to different collision domain. And in this scenario, we can improve the Ethernet bandwidth utilization and throughput, right? Because in the hub scenario, we have to wait until one terminal sends out the message successfully, then we can send the message. But in the switch, all the terminals can send the message at the same time. And about the switch, we also can adapt to different rates and different duplex conditions. For example, maybe one side the speed is 100 Mbps, but another side is 1 Gigabit. So the switch will automatically adapt the rate to become 100. So finally, we can direct it to transfer the message. So this is very different of the switch and the hub. Pay attention about the switch. One port, there is one collision domain. Okay, so this part about the LAN principle. And here also we have 2 questions. The first one, which of the following statements about the MAC address is true? And here we have 2 correct answers. Option A, Ethernet identifies hosts with MAC address. A MAC address is a logical address that is easy to change. Option C, the MAC address is fixed in the room and cannot be changed under normal circumstances. So option B and C, only one correct answer, right? And the option D, usually only the terminal host needs the MAC address, and the network device such as routers do not. So which answer is correct? And the second one, the question is, in the following topology, all the hosts can communicate normally, and no logical interface is configured on the switch. How many collision domains are there in the network? Pay attention about this topology. We have lots of terminals, and we have 3 network devices. One is hub and 2 switches. Pay attention. We see if we use hub to connect with each other, they belong to the same collision domain, right? But if we use a switch to connect with each other, one switch, one port is one collision domain. Different ports we can communicate with each other at the same time. So this is a principle and the difference between the hub and the switch. So what's the answer of this question? I hope you can do the practice and follow the next video. I will show you the correct answer. Thank you.
Hello guys, now I think you already see the video, right? So also have a brief summary for you. And the first one, we see about the local area network. This is a LAN network. And we also have so many protocols, but the typical one is the Ethernet network. And we have so many types of Ethernet protocol, like the faster Ethernet, like the Gigabit Ethernet. Also maybe now in our network, the bandwidth is higher, like 100 Gigabit, 400 Gigabit. And in the future, I will think the bandwidth will be higher than now. And we also know the principle of Sigma CD, how to avoid the conflict. And the very important one is a MAC address, right? We will use a unique address to identify a device. This one is a MAC address. That means different device, we will have a different MAC address. So besides the wired LAN, we also have the wireless LAN. This one we call is WLAN. And the typical protocol is 802.11. So if we deploy the wireless in our network, the customer can visit the internet anywhere, anytime. That's all about this part. Thank you.